Although all lines that are plotted using slope-intercept form follow the format of y equals mx plus b, some look a little different depending on their slope or y-intercept. Slope-intercept form is represented by y equals mx plus b. Y and x remain variables where m and b represent specific values. Y is my dependent variable. It represents a y coordinate. M is my slope. X is the independent variable. It can represent an x coordinate. And b is my y-intercept. This is the point on the y-axis where the line crosses. On your own, look at these equations below. Technically, these all would fall under the form of slope-intercept form. Certain things seem to be missing. Can these equations be graphed on a coordinate plane? Write out your answers, and we'll discuss in class. Sometimes we'll have a y-intercept that equals 0. That results in an equation that looks like this. We have our y, we have our slope, and we have our x, but we don't have a b. To graph this equation, we'll follow the same steps we would to graph any slope-intercept form equation. Identify the slope and the y-intercept. The slope is always attached to the x, and the y-intercept is always the value at the end. The y-intercept is the plus b portion of the equation. Our slope is always easy to find. It's connected to the x. It's the coefficient on our x variable. So I get 2. I always write slopes as fractions, so it would be 2 over 1. That way I have a rise and I have a run. Next I would look for my y-intercept, but there's nothing there. I just have y equals mx and no plus b. The only possible value that I could plug in for b that would make it drop out of the equation would be 0, since anything plus 0 is just anything. It's itself. So my y-intercept is 0, 0. So this graph passes through the y-axis at the origin, or right at the middle where the x and y axes meet. So I'm going to start by plotting the y-intercept. My y-intercept's my origin, so it's dead center. Use the slope to rise and run to your next point. My slope is 2 over 1, so I'm going to rise 2. That's 2 in a positive direction, so I'm going to go 2 up. And then I'm going to run. It's positive 1, so I'm going to run in a positive direction. Right is positive, left is negative. So I'm going to go 1 to the right. There's my next point. 2 points define a line, so I'm going to connect the points with a straight line. I can always find more than 2 points to double check my work. If I wanted to go in the opposite direction from the origin, I would take the opposite of my rise and the opposite of my run. If I went down 2 and left 1, that would still be a point on this line. This also helps if you're using a pre-drawn coordinate plane and your graph starts to go off of the coordinate plane. Try going in the opposite direction to find a point. If your slope equals 0, we would see an equation that looks like this. Y equals anything. In this case, y equals -4. We're going to start this problem just like we would any other slope-intercept form equation. Identify the slope and the y-intercept. If I compare this equation to y equals mx plus b, I have my y, and then I have just a constant, a value by itself. B is the only constant, because otherwise I would have a variable, x, on the right side of my equation. There's only one way to make that x disappear, and that's if m equals 0. Anything times 0 equals 0. So if I do that, I'm left with just whatever b is. So that means y equals -4 tells us what our y-intercept is. Because that x value drops out, we have to have had a slope of 0. My y-intercept is -4, so it's going to be 0, -4 as a y-intercept ordered pair. I'm going to plot the y-intercept. So I'm going to go to 0, -4, either using my skills from plotting ordered pairs or knowing that this line crosses the y-axis at -4, so there has to be a point there. Once my y-intercept is plotted, I'm going to use my slope to rise and run to the next point. 0 doesn't have a rise. It doesn't have a run. You have to keep in mind what 0 slope means. If I went skiing or sledding along a flat horizontal line, I would have 0 fun. So a horizontal line is 0 slope. I could keep going forever. Any point in any direction, as long as it remains horizontal, would give me a straight line if I connect the points. A shortcut with a problem like this is to notice that all lines that are y equals a single value are going to be perpendicular to the y-axis. More specifically, they're perpendicular, so they make a 90-degree angle at the y-intercept. So here I just drew a horizontal line that crosses through the y-axis at -4. It's that simple. Equations like x equals 2 can also be graphed. This is a case where the slope is undefined. Keep in mind what an undefined graph looks like. A graph that has a slope of 0 is horizontal. A graph that has a slope that's undefined is vertical. It's straight up and down. In this case, we actually can find the x-intercept. We know we're dealing with the x-intercept because x-intercepts have 0 in the y-coordinate. So if I plug a 0 in for y, I can get x by itself. All I need to do is plot my x-intercept. My x-intercept is going to be at 2, 0. Just like when y equals a value, when x equals a value, it's telling us where our x-intercept is. So I'm going to plot the point at 2, 0, or wherever x, or on the x-axis, equals 2. Sketch a vertical line that passes through the intercept. Since I automatically know that this slope is going to have an undefined vertical line, I'm going to find my x-intercept and just draw a line vertically through it. Let's try a couple together. Y equals 3/4 x. Let's try to find our y-intercept and our slope. There is no y-intercept, so that means my y-intercept is 0. It's at the origin. I have a slope 3/4, so I'm going to rise 3 and run 4. Connect the dots. Y equals -2. I can either look at the fact that there is no slope, so it's a 0 slope, which means I have a horizontal line. The y-intercept is -2. So at -2, there has to be a horizontal line that crosses at the axis at -2. For x equals 5, I'm going to find my x-intercept, which is going to be at 5. I'm going to plot it. This is an undefined slope, so it automatically is going to have a vertical line. On your own, try graphing the other 3 examples.